Welcome back students to the part 3 of today's session. In this module, we will be learning about the kinematic equations of motion. Let us refer to this velocity time graph. Let AD be the path of a particle. Let the velocity of the particle at the position A be u and the velocity at the position D be v. Let these time intervals be t equivalent to 0 and t is equivalent to t. Then from the figure it is clear that the distance BC is equivalent to u and the distance BD is equivalent to v. Therefore, the distance DC will be equivalent to v minus u. For deriving the first law of motion, we know that acceleration A is equivalent to change in velocity by time taken, which can be written as final velocity minus initial velocity by time taken. That is, A is equivalent to v minus u by t, where v is the final velocity, u is the initial velocity and t is the time taken. Cross multiplying, we get AT is equivalent to v minus u. Rearranging the equation, we get v is equivalent to u plus AT. Here A is the acceleration of the particle, t is the time taken, v is the final velocity and u is the initial velocity. This equation v equivalent to u plus AT is known as the first equation of motion. Coming to the derivation of second equation of motion, we shall refer to the velocity time graph that we had discussed earlier. So, we are familiar with the fact that distance or displacement is equivalent to area under the velocity time graph. So, from the figure, we know the area under the line AB will give you the distance or displacement. Taking the portion below AB, we can separate it into two. One as a triangle ABC and the other as a rectangle OACD. So, in order to get displacement, we have to find the area of the rectangle plus the area of triangle. We know area of a rectangle is equivalent to length into breadth, which is equivalent to OD into OA. And area of triangle ABC is equivalent to half BC into AC, which is half base into altitude. OD is marked as time t and OA is u. BC is equivalent to v minus u and AC is equivalent to t. Substituting the values of OD, OA, BC and AC, we get displacement S is equivalent to ut plus half at square. Here u is the initial velocity, t is the time taken and a is the acceleration of the particle. Coming to the third law of motion, the third equation of motion is derived by substituting the value of time from the first equation of motion. We know from the first equation of motion v is equivalent to u plus at that v minus u is equivalent to at or t is equivalent to v minus u divided by a. From second equation of motion, we have s is equivalent to ut plus half at square. Putting t is equivalent to v minus u by a in the above equation, we get s is equivalent to u into v minus u by a plus half a into v minus u by a the whole square. Solving this equation, we get 2as is equivalent to v square minus u square, or v square is equivalent to u square plus 2as. The three equations of motion can be written as v is equivalent to v0 plus at, x is equivalent to x0 plus v0t plus half at square, and v square is equivalent to v0 square plus 2a into x minus x0. Here, the displacement is taken as the final distance minus the initial distance, that is x minus x0, and initial velocity is written as v0. The derivation and the equations of motion are important, and you need to study the derivations also. Thank you, dear students.